a reminder first, how to configure spine in a fabric. So that's nothing new, so I'm going to go fast on that. So this is here spine 1, that is here on that first fabric 1, right? So you have some layer 3 circuits, okay, to interconnect the spine and the leaf. So this is nothing new here with OSPF, MTU, pay attention on that one. And then you have the loopback, right? So we have the loopback, and you see the loopback, there is no IP OSPF on that loopback. We'll see why. We are going to redistribute the loopback. And in the routing, that's what I have got here. In OSPF, I do a redistribute local loopback with a route map. The interest of doing that is I can associate a tag. Here, the tag, you can take whatever value you want. I take 1000 as an example. That's a tag value that defines a particular meaning. That meaning is this route is local. This is a local fabric loopback IP address. Then everything else, you know already about that. So this is okay. We have the spine that are root reflector will get some peering for the leaf. So I'm defining leaf peer group on that, where I've got some all the CX nodes member of that peer group with the leaf with an update source for loopback 0. Use the failover without BFD, failover, which get the benefit from the IGP OSPF and the FIB notification that, for instance, the route is removed from OSPF, and then immediately the BGP process is notified and the peer is getting down, so that it's accelerating the convergence. So failover is an important way. You have the community to be used. So generally, you will find in the previous white paper send community extended. Remember, both is extended plus standard. Standard might be used later on, so good to use both. So then the spine 2 is exactly the same. I'm not going to spend time on that. And the routing for spine 2. Right. Let's see now the leafs configuration. So first of all, nothing new, VSX. We are going to consider high ability in the data center. So it's all about VSX VTEP. So it's VSX configuration here. So there is nothing really new here. Okay, I'm going to configure my my ISL, my keep alive circuits, my links part of the ISL. Then I'm going to configure VSX. You can follow best practice for system MAC, please. You can use the route map for VSX synchronization. We talked about that yesterday. You will define a transit VLAN between CX nodes, primary and secondary, that is here 10, 19, in order to make sure that there is an IGP continuity for OSPF. Then you will define your VLAN for your local servers. You will obviously create your VSX lag to the servers. You will also have your link, physical link to the VSX lag. Nothing new here. For circuits, layer 3 circuits to the spine. So that's the reverse than we saw on the spine. Loopback. We have a loopback 0 that is unicast for loopback 0, and we have a loopback 1, remember, for the VSX logical VTEP. That IP is identical on the primary and on the secondary. Then I talk about that, a transit VLAN, so an associated layer 3 VLAN interface for the transit VLAN with an OSPF cost that is higher than the one for the uplink, so that you don't use that transit VLAN in nominal situation. You only use that one if there is uplinks, both uplinks failing. Now, VRF. So VRF, remember, we defined a route distinguisher. So that route distinguisher, we have a lot of debates internally. Remember, VSX, this is 2 independent control planes for the primary and the secondary. So logically, we should have a unique route distinguisher for the primary and a unique route distinguisher for the secondary. So that is an option. The first validated option was a common route distinguisher shared between the primary and the secondary. So that was all the previous paper and the documentation has been done with the common route distinguisher. There is more granularity for troubleshooting when you use a unique route distinguisher, because you really know which nodes, is it the primary or the secondary, sending the route. So that's a bit better. However, you will get a lot of routes. So for all the layer 3 VNI, you are going to pretty much double the number of routes for that. So this is, I would say, prefer to have a common route distinguisher. So we stick to the previous recommendation, but think that nothing prevents the customer to use a unique route distinguisher. And I discuss with customers that actually prefer to use that one. So just to be aware of that. Oops, sorry, going a bit fast. The route target, the proposal for the local scope route target is still the same, local AS and colon the ID of your VRF. ARP suppression, you know already about that. So for ARP and ND, so here I put ND, but IPv6 is out of the scope of the multi-fabric. However, you can still use IPv6 local to the fabric. It's just the multi-fabric aspect that is not supported as of 10.09. So you can still have IPv6 local, and do not use IPv6 between fabric, and that can still be used locally. Local SVI, we talk about that. It is useful when you do not have the same IP between the SVI and the active gateway. So again, 10.09.10 maintenance release should provide that. So this would be no longer required if you always have IP address identical for SVI and active gateway. The route distinguisher auto for the inside the VLAN of EVPN context is fine, because the format by default is the VTEP Anycast loopback and colon the VLAN ID, exactly what we want. So keep that so that you don't have to define it. And the route target for it must be set manually. Think about redistributing the host route. This is always good when you have a VLAN that is stretched between two multiple VTEP. It's allow us to define what is the right VTEP to send the traffic to. Again, yes, the route target, we talk about that, just a point. Route target auto, do not use that, right? It's not at all something we can use in operation when you have external BGP model, because it's impossible to anticipate how this is calculated. You need to check remotely what is the value and then put a very complex value. So don't use auto for route target. So I think we covered that. Nothing new, but just more a reminder. Okay. Here I anticipate the next release, so I use SVI IP identical to active gateway on VRF1. On VRF2, I use different IP so that you in the single slide you have two models, but you can articulate those differences if you want. Please follow the best practice from the MAC address used for active gateway. Okay, we have in the VSX, you have a best practice for that. The IPv6 active gateway, again, this is for single fabric only, must be a link local address. Okay, this is the one that is used for roaming clients. And for DHCP, we're going to talk about that here. The relay is configured. Here, this time we see with the DHCP server hosted in the default VRF. So typically this is used for migration where you have a DHCP server that is on the default VRF and you migrate some VM in a newly created tenant VRF. This is very useful to have that. You will source the DHCP relay from the loopback one, which is the loopback shared between primary and secondary. Why is that? Because the answer of the DHCP relay may hit one or the other of the VSX cluster, right? Of the one node or the other. So you need to make sure that you source from the loopback one. So that's pretty much what I covered. Yes, for IPv6, you will use the same link local address on primary and secondary for the active gateway IPv6 address, and that would be the same link local on all the VTEPs where you stretch your VLAN. And you will use as well the same global unicast address for the SVI IPv6 address on all VTEPs, including the same IPv6 for primary and secondary when we are in 10.09.0010 maintenance release. So optional for the tenant VRF, we have some loopback to be defined. So if your DHCP server is inside the tenant VRF, think that you need to have some anycast. So by anycast, I mean it's an IP address that is identical on the VSX primary and secondary in order to source that DHCP relay request to the server. And that is inside VRF1. So pay attention on that one, but this is optional. Maybe you don't have the DHCP server in that VRF1, so then you do not need that loopback. However, one that is not optional, well, it is still optional, but really much recommended for troubleshooting, is to set up a loopback address inside the tenant VRF for troubleshooting, for ping and trace route, in order to make sure that as you have your SVI IP identical to active gateway, and you've got all the explanation on the slide here, the return traffic, for instance, may hit, and this is what I explained here with the ping, right? So here, imagine that you are on the 8325-1, and you want to ping a VM that is connected somewhere on another top of rack. The ping will be encapsulated into VXLAN, will be routed through the underlay, let's say through spine 1, let's say, okay, and going to from spine 1 to that leaf 2A, the VSX primary of that VTEP. Then going to the server, and then the server reply. Let's say the server reply and the traffic hits the secondary, and the secondary send the traffic to the spine, and then hit the secondary here. So that will happen, okay? So if you source the traffic from that ping with the SVI IP, it will not answer. It will that guy will never receive the packet. And actually, if you have a distributed IP anycast gateway for the SVI, it's actually that guy that will receive the packet. So your packet will not be received. So, and that IP must be unique, okay, distributed and in the routing table in the VRF everywhere must be unique. But even if this is unique, the secondary may receive that packet because the destination for next hop is the VXLAN IP address. Okay, so this is the loopback 0, the loopback 1, 10.3 here in my example. So in order to make sure that the primary that initiate the ping receive the reply, you need to have a transit VLAN per VRF. So that's an extra configuration to be performed as well, and this is pretty much recommended for troubleshooting. It's something obvious that the network guy in operation would have to troubleshoot and have the reachability for workloads. So for that, you will have as well to define a transit VLAN per VRF, so attaching a layer 3 VNI for that VRF, and then use a route. So that's very simple. This is just, so here I put the primary and the bottom I put the secondary. This is just a route for that unicast loopback in the VRF that you define, that with the next hop is just the peer VSX. So that's it. So that's quite a simple configuration just to make sure that we have a ping and trace route working. And for trace routing as well, from any workload to any workload that would be not in the same subnet, the loopback that you have in that VRF will be useful in order to see the nodes. So pretty much that loopback 12 that I put here is very useful. So you've got all the explanation on that slide. Then you configure the VXLAN interface. So think about the counter, that is pretty much useful. The source IP is obviously the loopback one shared between primary and secondary. We talk about that. And then you define the VLAN mapping and VNI VLAN mapping. And we'll get back to that because this is quite important, for especially on the border. But here we are on a regular leaf for the time being. So you define your local, what are locally connected here. And of course, the virtual MAC, which is used for routing. So routing is optional. You may not use L3 VNI in your setup, but if this is used, that virtual MAC is extremely important. It must be the same on the primary and secondary of the same VSX cluster. However, it must be different for any other VTEP. So for a single fabric, you configure your local VLAN in that VXLAN interface. However, for multi-fabric, think about that on if you stretch a VLAN, you need to add the remote VLAN, non-local to the border. So typically on the border, so that's the case here in VTEP 1, you would add the mapping for the VLAN that is not local to that border, but the VLAN that is local to the fabric and that is required to be extended. Okay, so on top of the local VLAN that are distributing layer 2 connectivity to servers on the border, you will add the VLAN that are used in the fabric in order to stretch the VLAN. For routing on the primary, so think about that again. We are using that connected OSPF route map for OSPF, okay, and everything that we already discussed is there, okay. So we have IBGP between to the spine with the loopback address. We use the send community both. Well, you have all the details here in the slide, and we also use in the VRF local redistribution for loopback. That is, I'm going to cover that. That is important for especially on the border, and you can as well redistribute the connected route map with a filter with prefix list for the SVI.